right. Good morning, guys. It is early in the morning. I'm going to do a little bit of a pre-work video today. Get started early. So let's dive right into Advent of Code. I've got about 40 or so minutes. We'll see how far we can get on this video. Maybe we can knock out both parts. Not 100% sure, so I might skip over a couple of things. But I'm going to try to help you or try to walk you through my thought process. One cool thing about Advent of Code that maybe I skipped over earlier is that as you complete each task, this becomes the intent is for it to reveal some sort of image or picture. So your progression from day 1 to 25, you're going to have something revealed at the end of it. So you're going to see here, I'm through 3 days and we're kind of starting to see something. If I go to a previous event, which I've done in the past, you can see that there is something manifested here as well. And these bits shift in accordance with that. So, but let's just stick with 2022 for right now. So let's dive into day 4. So space needs to be cleared before the last supplies can be unloaded from the ships. And so several elves have been assigned the job of cleaning up sections of the camp. Every section has a unique ID number, and each elf is assigned a range of section IDs. However, as some of the elves compare their section assignments with each other, they've noticed that many of the assignments overlap. To try to quickly find the overlap and reduce duplicated efforts, the elves pair up and make a big list of the section assignments for each pair, which is your puzzle input. For example, consider the following list of section assignment pairs. 2, 4, 6, 8, so on and so forth. For the first few pairs, this list means within the first pair of elves, the first elf is assigned section 2, 4. Okay, first elf. And the second elf was assigned section 6, 8. 6, 8. Okay, so this is elf 1 and elf 2, so we're probably going to be comparing those. Those in the second pair were each assigned 2 sections. Those in the third pair were each assigned 3 sections. One got section 5, 6, 7, while the other got 7 plus 8 and 9. So these are ranges of sections. So the start of the section, end of the section. Okay, cool. Here's a visual example. Let's use a single digit section IDs to make it easier to draw. Your actual list might contain larger numbers. Visually, these pairs of sections assignments look like this. Okay, great. So we can kind of see visually. Some of the pairs have noticed that one of their assignments fully contains the other. For example, 2 through 8 fully contains 3 through 7, and 6 through 6 is fully contained by 4 through 6. Okay, so if we look at the example 2 through 8 and 3 through 7, you can see here that the first guy goes from 2 to 8 and 3 through 7 is in that exact same section. There's complete overlap. And then the second example, 6, 6, and 4, 6. So this one here where elf number 2 has 3 sections, 4, 5, and 6, and overlaps once here. So the pair would be exclusively cleaning sections their partners will already be cleaning, so these seem like the most in need of reconsideration. In this example, there are 2 such pairs. And how many assignment pairs does one range fully contain another? Okay, so just reading through this, I think this is pretty straightforward. We can grab, since this is our input data, we grab elf 1, and we have 2 and 4 as the min and max values. And we see if 2 is greater than 6 and if 4 is less than 8. And if so, we know that elf 1 is fully contained inside elf 2. If that's not true, then we're going to do the inverse and see if 6 is fully contained, is greater than 2, and if 8 is less than 4. And so we'll just check both ways. There might be a slightly different way to do that, but I just think, in this case, straightforward approach works. So I'm just trying to think if I've got any other edge cases. I think this will work for case number 1 here. We've got some inputs, so we can grab this real quick as our test, and we know that the count is 2. So we can go ahead and, let's see here. Can I change this to this kind of input? Yeah. Well, on the looks report, we're going to go with that just to get rid of any other spaces. And so we're going to AOC this and then score it, and we'll get back a score. So we want for this, we can just say like for a given set of input. If we look at one of the examples, 6, 6, and 4 through 6, here that expected value is a 1. And if we take this, let's just say, and we give an expected of 0 and an input of that. And what we'll do is we'll just have the AOC function go ahead and just return a 1 if there is an overlap and a 0 if there's not. And so that'll be our base function, and then this will give us our total score. So let's go ahead and just get right into AOC. What problems do I have here? Oh, I hate when VS Code does that. It sometimes keeps a file open in memory, and then it does process against that. It makes it look like you're having issues when you're really not, so you just got to close out of them. Okay, so we're going to run this. Obviously, it's going to fail. And we got 0 for the first one, which is our default, and then that should be a 1. So should be straightforward. Let's go into AOC. So for AOC, this is just going to be the Advent of Code per line processing. Maybe I should recall it something else than AOC. But here we are. So we're going to do a strings.split, and we're going to split the input separated by a comma first, which gives us our 2 L's. So there's that. And then we're going to strings dot yeah, we'll just call this E. So we're going to split I guess we could also just like remove the comma because it's not important. Well, no, never mind. We're going to keep going with this. We're going to split E sub 0, which is the first elf, by a dash, and that's going to give us E1, and then the second index, or index 1, the second one in the list, by a dash, and that'll give us E2. And then we're going to do I do A. Is it I A? I always forget this. Like, there's these functions that I always forget. Oh, string over IDA. See, yeah, that was. Yeah, there we go. So this is going to be E1 min, so elf1 min. And then we're going to do max. And then we're going to do the same thing for E2. Also, I'm just going to swallow the error. I'm probably going to regret this later, but this is where Go has its downfalls. It's just there's so much error handling that has to be done. All right, so we've got the min max, and what we want to do is we want to say that if E1 min is greater than or equal to E2 min and E1 max is less than or equal to E2 max, return 1. So I think what we're saying is that if E2 is, if our min is greater than E1 min and our max is less than or equal to our E1 max, that tells us that everything that's in E2 is contained within E1. And then we're just going to flip these signs here and here to be 2 and 1. And so we're going to do the inverse. And I think that should cover it. So if we run this, that passes. And then we'll check our test score. Expected, our expected should be 2 here. So that actually worked beautifully. Okay, so that passes. So we're going to now run day 4. Because I failed to do 2 things. First thing is our input data needs to change to day 4. And it makes sense because the inputs. And then the second thing is we need to grab this value. So go into our data, new file, day 4 1.txt, paste that. All right, it's cooking. 487. That's right. All right, cool. That was an easy one. Let's go ahead and continue to part 2. It seems like there is still quite a bit of duplicate work planned. Instead, the elves would like to know the number of pairs that overlap at all. In the above example, the first 2 pairs don't overlap, while the remaining 4 pairs do overlap. All the section 3s through 7s, yep. So in this example, the number of overlapping assignment pairs is 4. So we can do very similar operation. We could just simply add onto our function and add 2 additional conditions. So I guess really it would be 4 additional conditions. So if we want to maintain like part 1 and part 2, we can, and I can just create an AOC2. Really, maybe I should label these functions part 1, part 2. But the way we could look at this is we've already have these 2 conditions, which is everything is fully contained within. But then there's this edge case where the min might start outside the min and the max might start outside the max. But one of the 2 numbers is going to be contained within the other. In order for them to have some overlap, you're going to have one of them. So if we go back to this example here, like in this example, 4 is within 2 and 6. And so we can say, do we have just one number inside the overlap? And we can remove our other condition if we want. Same thing for here. 6 is inside 4 and 6. 3 is greater than 2 and it's less than 8. So is 7. So it actually has it in both locations here. 5 and 7. 7 is contained within that, but not fully. So we just need to check to see, instead of is, we could just say if, let's just say e1.min is greater than equal to e2.min and e2.min or e2min, I'm sorry, e1. If e1 min is greater than e2 min and e1 min is less than or equal to e2 max, then we've got that condition, right? And so we could do the same thing here where these become ones. Well, let me copy this line. And then these become 2 and these become 1. Okay. So that should work. We can then just go back to this and we can test AOC2, which ironically, I think, yeah, this should still pass on both of these because we don't have any overlap, but we do have another condition we want to test. So do overlap. So 5, 7, 7, 9. So we should see an overlap on this one. So if we do, sorry, expected 1 input 5, 7, and 9, we overlap, which is what we want. So now we can enhance our test over here, and we can add AOC2, and we can say that our expected is, let's just double check, but I think they said 4, right? It's 4 pairs. Okay. So this is overlapping assignment pairs 4. Okay, so let's run this, and we pass. Okay, great. So did the input change? Oh, nope, it has not changed. Okay, so if we go back to our day 4, then we can simply keep doing that. I'm going to change my template here a little bit and call this part 1. And then part 2 is AOC2. I do know from past experience that sometimes these can take a while to run. And we don't have that problem yet, but we may have to not print both outputs, or we can do it concurrently. All right, so, let me change that. So 849, submit, and there we go. So that was quick, that was easy. Day 4 is complete. Again, pretty straightforward. We're just doing some string parsing. There are some things I do really like Go, but there are some things that with error handling that can get really tedious if I was to try to capture all these errors. If I was in a production work environment, I would have definitely captured and checked every single one of these errors. I also would have done some length checks here on the slices, just to make sure that I wasn't going to get an index out of bounds errors. So I mean, forgive my laziness here, but the point here is to solve the puzzle. We're not building production apps in this environment. But again, a little early morning coding challenge never hurt anybody. We got this one in pretty complete and pretty fast speed. So take a look at it. We'll keep iterating through these in preparation for the 2023 AOC. And we'll just kind of run through these, kind of get our minds in the right motive, and then we're going to change this template. I think what I'll probably do is change this to part 1 and part 2, since I typically have different processing methods, and maybe even just call this, score or something. I don't know yet, or processing. I'll iterate on it a little bit, and we'll come up with something a little bit better. But yeah. So, great chatting with you guys. Please like and subscribe, and I'll see you next time.